Did you know that one of the longest living vertebrates on Earth is a shark that swims through Arctic waters almost entirely in darkness? The Greenland shark can live for at least 250 years, and some individuals may exceed 400 years in age. That means sharks alive today may have been born before the Industrial Revolution began. The Greenland shark, scientifically known as Somniosus microcephalus, inhabits the cold North Atlantic and Arctic Oceans. It is commonly found at depths between 200 and 2,000 meters, where water temperatures remain close to freezing. Adults typically reach lengths of 4 to 6 meters, although some large individuals may exceed 7 meters and weigh over 1,000 kilograms. Unlike fast-swimming predators such as great white sharks or makos, the Greenland shark survives using an entirely different strategy. It moves slowly, conserves energy, and thrives in one of the harshest marine environments on Earth. Scientists believe its extremely low metabolism is one of the primary reasons for its unusual lifespan. One of the Greenland shark's most recognizable features is its cloudy eyes. Many individuals carry a parasitic copepod attached to the cornea. This parasite, Omatocoita elongata, can partially damage the shark's vision over time. However, eyesight is not the shark's primary hunting sense. In deep Arctic water, visibility is limited, so the shark relies more heavily on smell and the detection of vibrations in the water. The Greenland shark is often described as a slow-moving scavenger, but research shows it is also capable of active predation. Its diet includes fish, squid, seals, and carrion. Scientists have even discovered remains of horses and reindeer in the stomachs of some individuals, likely carried into the oceans through rivers or ice movement. Despite swimming at speeds often below 1 kilometer per hour, the shark is capable of ambushing sleeping seals in Arctic waters. Its slow pace is directly connected to the cold environment it inhabits. Near freezing water dramatically slows chemical reactions inside the body. This reduces metabolic stress and lowers the amount of cellular damage that accumulates over time. In other words, the Greenland shark's body ages very slowly, because nearly every biological process operates at a reduced rate. The shark also possesses unique chemical adaptations that allow it to survive in deep, cold water. Its tissues contain high concentrations of urea and trimethylamine oxide, or TMAO. These compounds stabilize proteins and prevent cellular structures from breaking down under intense pressure and low temperatures. Without these adaptations, many biological systems would fail in Arctic deep-sea conditions. These chemicals also explain why Greenland shark meat is toxic when eaten fresh. High concentrations of urea-related compounds can affect the nervous system and produce symptoms similar to severe intoxication. Historically, sled dogs that consumed raw Greenland shark meat were reported to behave erratically or collapse. In Iceland, the meat is traditionally fermented and dried for several months to remove toxic compounds before consumption. This fermented dish is known as hákarl. For decades, scientists suspected Greenland sharks lived unusually long lives, but confirming their age was difficult. Sharks do not possess hard bones like mammals, which means traditional aging methods are less reliable. The breakthrough came through the shark's eyes. Inside the eye lens is a central core made of proteins formed before birth. These proteins remain largely unchanged throughout the animal's life. Researchers used radiocarbon dating techniques on these eye lenses to estimate the age of several sharks. By comparing carbon isotope levels, including signals produced by nuclear testing during the 1950s and 1960s, scientists estimated that the oldest individuals in the study were approximately 392 years old, with a possible margin extending beyond 500 years. This discovery made the Greenland shark the longest-lived known vertebrate on Earth. Its growth rate is equally unusual. Scientists estimate Greenland sharks grow less than 1 centimeter per year. females may not reach sexual maturity until approximately 150 years of age. This means a single generation can span longer than the average human lifespan. That slow reproduction creates major conservation challenges. Species that mature slowly cannot quickly recover from population declines. Greenland sharks are vulnerable to accidental capture in fishing gear, climate change, and long-term pollution exposure. Heavy metals and industrial contaminants accumulate in their tissues over decades or even centuries. Despite their enormous age, many aspects of Greenland shark biology remain unknown. Scientists still do not know exactly where they mate or give birth. Very few juvenile sharks have ever been observed in the wild. Much of their life cycle remains hidden beneath Arctic waters. Researchers continued tracking Greenland sharks using satellite tags and deep-sea cameras. These studies reveal that the sharks travel across vast regions of the North Atlantic, moving between deep trenches, fjords, and continental slopes. Although they appear slow and passive, they are highly adapted predators capable of surviving in environments where few large animals can endure. The Greenland shark also offers scientists a rare opportunity to study aging itself. Because its cells function for centuries with relatively limited deterioration, researchers hope the species may provide insights into metabolism, cellular maintenance, and long-term biological stability. While humans cannot replicate the shark's extreme lifespan, understanding how its body reduces damage over time could improve scientific knowledge about aging in other vertebrates. Today, the Greenland shark remains one of the ocean's least understood apex predators. It has survived through centuries of climate shifts, changing ecosystems, and human expansion into the Arctic. Yet, its future may depend on how quickly modern oceans continue to change. And that raises an important question. If one of Earth's oldest vertebrates requires centuries to replace itself, can it adapt fast enough to survive the rapidly changing conditions of the modern world?